So in this example, I'm going to show you how to create a simple table in MySQL. We're going to create a table called gender. The syntax starts with create table, and if not exists is not mandatory. However, as a best practice, I recommend you to use this statement as well, along with create table. So create table, if not exists, and the table name. In this case, the table name is gender. So create table will create the table. If not exists, we'll check if the table already exists or not. If the table already exists, it will throw an error saying that, hey, the table already exists, you cannot create the table again. If the table doesn't exist, it will continue with rest of the statement. And open brackets here, and then here is the column name, and followed by the data types. In MySQL, there are a lot of data types, it's the role of your architect or the database developer to identify the right data types for the columns that you create in a table. So in this case, the first column is gender ID. Usually the ID columns are tagged by integer data types. In this case, I'm using tinyInt. The data types comes with different flavors, even though of the same kind. For example, within the integer data type family, you have tinyInt, small int, medium int, big int. So all these different types carry different storage sizes. I felt like there are not many genders in this world. So if I allocate int for gender ID, it's an overkill. You're allocating a lot of storage for storing a small amount of data. So hence, as a SQL developer or the database architect, it's your role to identify the right data type and assign it to the respective columns. Definitely, it will show some impact depending on the size of your database. Assigning the right data type to your columns will improve the storage space allocation for your tables within the database. So gender ID, I'm tagging it with tinyInt, and then followed by the second column. So followed by a comma, and then the second column, gender underscore short description. In this case, I'm going with character data type, followed by an allocation of the size for the character data type. Remember, there are many flavors within the character data types as well. For example, short description here is tagged with char, and gender underscore long description, the third column here is assigned varchar and the size of 10. So the difference is for the char it's a fixed length, which means the character data type always takes the amount of space regardless of what you store, right? But whereas a varchar, the size varies depending on the specific string that is stored, right? So in this case, short description is, for example, for male, it's I'm going to store M in here. For female, I'm going to store F. And then for others, I'm going to store O in here. So it's only one character that I'm going to store here. So I'm going to limit my character length to 1, right? And I'm going to use char as my data type. You can also use varchar, but in this case, it's a very controlled storage columns, so I'm going to use char. And also, as an example, I want to provide an example for you as well. Gender underscore, then followed by comma. The third column is gender underscore long description, long desk, and then followed by the data type and the size here. Here, I'm going to use varchar. Varchar is also a data type which is used to store character strings. And then comma, the fourth column is record insert date, and the the fifth column is record update date. These two columns I'm adding as a best practice. So whenever you create a table, these two columns are added as a best practice. Record insert date will record the date and timestamp when this record got inserted into this table. And then record update date will carry the same date. However, when you update the record in this table, the record insert date will not change, but the record update date will change to the date when the record got updated. So you can keep track of when the records are being changed and updated.